Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York, and this is 5th grade math, Module 6, Lesson 16. Today we're going to construct perpendicular line segments and analyze the relationship of the coordinate pairs. So we're going to kind of be doing something similar to what we did in Lesson 14 with parallel lines, except this time we're going to be working with perpendicular lines. So it says, use the coordinate plane below to complete the following tasks. Draw a line segment PQ. So my ruler here is a straight edge. And this time it wants me to just draw a line segment. So here to here, line segment PQ. Now it asks us to plot point R, which is 3, 8. So 3 here and 8 up here. Now draw line segment PR. So this is R right here. And I connect P and R. To explain how you know that RPQ, angle RPQ, is a right angle without measuring it. So I need to figure out how I know this is a right angle. And they're talking about this angle right in here. So again, if we look at what we do to this point here, we go over 1 and up 1, 2, 3, 4. When we move from that to point Q, we're going to go down 1 and over 1, 2, 3, 4. So we're really translating it the same way. We're moving that point relative to the y-axis to make point R the same way that we're moving Q relative to the x-axis. So like if this time I go over to the right and up 4, this time I'm going over 4, either down 1 and over 4 or over 4 and down 1. So I'm kind of just doing the opposite to find point Q. And if I turned this whole angle and I turned it this way toward my x-axis, you can kind of see that if I move this over 1 and I move this up 1, and this angle would be the same angle, and it would give us a nice clean corner on one of these boxes, which would give us a 90-degree angle as well, or a right angle. Letter E says compare the coordinates of points P and Q. What is the difference of the x coordinates and the y coordinates? So let's look at P and Q. The difference of the x coordinates and the y coordinates. P is 2, 4. So P is, I guess I'll just do P, not really equals, but like a colon here. P is 2, 4. And Q is 6, 3. So what is the difference of the x coordinates and the difference of the y coordinates? The difference between the x coordinates would be 4. 6 minus 2 is 4. And the y coordinates, 4 and 3 is 1. Compare these to the points P and R. What is the difference in the x coordinates? What's the difference in the y coordinates? So again, P is 2, 4, and R is 3, 8. So the difference between our x coordinates now is 1, and the difference between our y coordinates is 8 minus 4, which is 4. So again, we're moving along that x-axis four places to get from P to Q, and one along our y-axis. And then when we're talking about from P to R, we're moving one space in our x-axis and four on our y-axis. That's kind of what what we were just explaining about how we know that RPQ is a right angle without actually having to measure it. And of course we could always put something that we know is square, like this ruler in the corner of it, and that's a right angle. We can see that that fits right nicely in there. That's square. Even the corner of another piece of paper I could put in there. That's square, and it would fit right into there as a right angle. A couple ways that we can look at it. Letter G says, what is the relationship of the differences you found in parts E and F to the triangles of which these two segments are a part? So I think what they're trying to say here is, if I use this triangle, I can make this triangle right here. 1 over, 4 down, I can make a triangle there. And then I could do the same thing here. I'd be going down 1 and then over 4. And these two triangles here, they're really the same triangle. We've just taken this one and we've moved it down here. So here we have a triangle, and here we have a triangle. And again, it's down 1 over 4, or up 4 and over 1. Those are going to be the same shifts in coordinates, just along the x-axis for PQ and along the y-axis for PR.